Hello, this is Mike at GameFromScratch, and today we're going to look at creating a complete game from scratch using a product called Phaser. Phaser is a great little HTML5 game engine or library, kind of straddles the line between the two. It's a wonderful little product. I've actually been running an ongoing series on GameFromScratch.com. You can see up in front of you, which is on using Phaser with TypeScript. I'm going to be using TypeScript again today, and I'm not actually going to get into too much detail on working with Phaser. Every single thing I do today is actually covered in these tutorials. Everything except for one line of code, which hopefully I'll remind to tell you. But for the most part, everything we are going to touch on here today, I've already actually covered the how-to on GameFromScratch.com. So if you want, go to this tutorial series if you're confused about something we're doing, and you can get more detail here. Of course, Phaser also has pretty extensive documentation. Mind you, it's mostly in HTML. If you're unfamiliar, TypeScript sort of it's Microsoft. Don't worry about that. It's cross-platform and very open source. But Microsoft implemented this JavaScript++ language. It's along the same lines as the likes of Dart from Google or CoffeeScript, etc. It's sort of a better JavaScript. Because JavaScript as a programming language has issues, especially for sensibility and modularity. And this is where TypeScript comes in. TypeScript you can probably look at as a stopgap actually, because with ECMAScript 6 coming out, a lot of the functionality is actually going to be available. Unfortunately, it's not there yet, so TypeScript makes JavaScript a much less awful language. Now, unlike CoffeeScript or Dart, TypeScript is also JavaScript. It's a superset of the language, so all JavaScript works in TypeScript. So it makes it kind of a nice language to work with, and it's actually transpiled down to JavaScript code that is human readable. So even if you're not a big TypeScript fan, you should be able to get a lot out of this tutorial. Next up, I'm going to move along fairly quickly. I want to get this video done in less than an hour, and creating a complete game in less than an hour is going to be a trick. So the very first thing we need to do is make our game quite simple. Here's a bit of a spoiler. Here's the game we're going to create. It's an endless walker, I'll call it, and it's a video game by the very basic definition of the word. There's not a lot to it. So here's your title screen. You pop in, display your title screen, wait for user click, and here's your game. There you are, idly standing there, background going. You press the right arrow to start walking, left arrow repeatedly to slow down, and then right arrow to speed up. And you've probably played an endless runner before. This is an endless walker. And in all honesty, yes, there's a horrible seam there. That was me being lazy with the art generation. But this is it. This is the extent of the game we're going to create. But there's actually a lot going on here. There's all of the basic framework of a game is there. There's sound effects being played, there's animation, there's responding to input, there's background scrolling, there's state changes, and it's actually coded in a way that you could make a larger project out of. A lot of people struggle with when they're starting with an HTML project or game project in general of how do I organize my code? Well, when you're done, you're going to have a way to do so. So this is the extent of the game, and then you hit the escape key, it brings you to the final screen, and then you touch that, and it's the circle of life. We start all over again. Okay, so that's the game we're going to create. We're going to set it, and we're going to create that hopefully in less than an hour. So let's jump right in. First off, we're going to be doing everything in Visual Studio. It's not a requirement, but Visual Studio Community 2013 is now completely free. You have to register after 30 days, but you can download it and use it for free, and it's a great IDE, and it's probably the best way to do TypeScript development. You can, of course, use Node to download TypeScript's compiler and work completely from the command line. There's some support in Sublime Text. There's great support in IntelliJ's WebStorm. So there are options out there, but I'm going to go ahead and use Visual Studio. So if you're on a different platform, obviously you're going to have to use a different development environment. But in this case, this is what I'm using. It's not going to impact much. There's IDE-specific stuff is pretty much non-existent in this example. So we're creating a game called Extreme Walkign Simulator. It's an HTML application using TypeScript. So just go ahead and create that. There we go. So it's going to just generate us an app.ts. Let me just get the solution up over here. Alright, let me pause for a sec. I don't know if I can do a presentation. Okay, I had to install the Visual Studio's productivity pack, but this should be a little bit more readable for you, I hope. If not, I apologize. It's about the best I can do right now in Visual Studio. We're still making it accessible. Alright, there we can go. So hopefully that font's much more readable. We'll have to do a bit more scrolling as it stands, but it should carry over a little bit better in video. Let me just also pop full screen. All right, there we go. Actually, I don't want to do that yet. So I'm going to need to make some folders. So here it is. It starts us off with this TS file, which is basically you can think of as your main. This is where your program starts as app.ts. We're going to go ahead and get rid of all of this in a minute. But first, I'm going to set up some directories that we're going to ultimately use to structure our programming as we go. We're going to want one. First off, one for our graphics, one for our audio. We will call the first one, so just add new folder. We'll call one graphics. We will call one sounds. And then we're going to want some just for organizing our code. In this case, we don't have a ton of code. It could all go in the root, but it's a little bit cleaner to just start breaking things out. So we're going to have game objects and states. I'll explain those both a little bit further when I get on. Those are names I've created. You can call them whatever you want. But game objects are the entities in your game, and states are pretty much the activities or actions in your game. So that's a kind of a bad description. States more like a doing something. So you've got, we're going to use three states. One is going to be for the title screen, one is for the game itself, and one is for the game over screen. So kind of think of them as like execution modes or ways that your program runs. So they're almost like little mini programs within your program. Those are states. And that's how we're going to organize our code down, keep it nice and clean. So go ahead and create each one of those. Additionally, by the way, all this code is being pushed out to GitHub, and I will also create a blog post that will be linked below, so you can get this code at any time and go look it up. So if something you see here on screen is a little unclear, just come on back to it. Go to the website or go to GitHub, which I'll link also, and you can see the code firsthand. It might vary slightly from what I'm typing because I've actually already written this code, as you saw it running, but it will be very, very, very similar. So if you get confused with something we're doing, you can always check out the code. First off, so we got our HTML class here. This is just our basic container for our object. We don't really need to do anything. We're going to be writing over. We need a content div that we're going to like push things into. We don't want a header like so. All right. So basically, we have an empty body with a div named content that we're going to write into. The last thing that you see here, this one's very important, is this is what calls our app.js. Notice the JavaScript extension there. It's a TS file, but it's ultimately going to be compiled down to a JS file. As we add more and more code here, like different dependencies, or we start adding new JS files to our project, we're going to be adding them here as script dependencies. There's a module system built into TypeScript. It's changed as the language evolved, but I'll go with this route. It's kind of probably the easiest to understand, so we'll stick with just using a standard HTML style script includes like this. So this is what actually causes our app.ts code, or the JS code that it ultimately generates, to be run, is this inclusion right here. Up here we'll just change our title's name to Extreme Walkign Simulator, and we'll be coming back here again and again to keep adding new modules, including, very importantly, Phaser. So let's actually just go ahead and get that now. We need to go to phaser.io and go to the download and get started. This will bring us over to their GitHub page. And what you want to do is go into the build, and we're going to use the most recent version right here. So we're going to grab phaser.js. Now it's very important here that you grab the raw, unedited version. So just go in here and do raw, right click, and then save that link. And that will go into your projects folder there. All right, we'll save it into the root. So phaser.js, we want saved there. We also want we don't need the minified version. What's in custom? Nothing. Okay, we also need to go over here and get the TypeScript definitions. These are basically definition files mapped from TypeScript types over to JavaScript types. They're what allow you to have typing in your TypeScript file. So they generate a set for you, as you can see, updated 10 days ago. So they stay pretty current. We're just going to go ahead and grab that guy. So it opens up. There you can see, like, it's basically just a definition of all of the various objects and classes that are available in Phaser, just TypeScript form. So we're going to go ahead, grab the raw version again, and save it down to same folder. And we shall grab, probably don't need the pixie types, but we'll grab them anyways, just in case you're curious. Pixie is the actual 2D renderer that Phaser is built over. So now that we have those TypeScript files, we're going to go back over to our class here, and we're just going to add a dependency. We're going to add the dependency earlier than this guy. So we just go script source spelt right equals and then phaser.js. Like so. Now you'll notice it didn't actually add it here, so we'll just do an add existing item, and we will add phaser, and pixie, like so. So now they're part of our project. So that way, if you were typing it here now, it would have actually. Here, let's match case. Be a good little cross-platform citizen. There we go. So now our Phaser source files are included. We can start using the JavaScript library. And then let's switch it back over to TypeScript now. So that's our HTML file. That's what's loaded in the browser. And basically all it does is calls app.ts or app.js, but app.ts will ultimately generate app.js. So this is our entry point. This is where we want to get started. And let's just make a very simple one first. And we'll get rid of all the view. I use some. This is kind of a little bit gratuitous. You don't really need to modularize it, but this is kind of like a namespace in any other language. This is the TypeScript equivalent, and then we're going to export our class out of it. Extreme Walkign Simulator, like so. All right. Now, once again, the Phaser-specific stuff I'm not going to cover in detail. You've got to go to GameFromScratch.com if you want more details on any of this. Every single thing, except for one line of code, is covered on the website. Just go ahead and create a constructor. This is a JavaScript invention, but basically this is going to be called when our code is created. And we want, let's see, we're going to want a Phaser game reference. So game is a phaser.game, like so. And then on construction, we're just going to go ahead and create our game. Phaser.game. We'll pass in our ideal resolution or our internal rendering resolution. That phaser.auto is saying either pick between canvas or WebGL. It lets Phaser decide which one it's going to go ahead and use. And this is key. That is the name of the HTML element in which to render. So we'll pass that in. And then finally, a configuration of states. And we're going to be creating a number of states, ultimately. This is a little confusing, because actually this is more like, these are the functions I call. So they called it state up here, which I hate the name of, because we actually use state for something else later on. But those are the callback functions that we are going to implement. There's 4 options, I believe, available. Create, preload, render, and update, I believe, are them. And the ones we're going to use in this class are actually create. It's not auto-completing because I haven't actually defined that class yet, and preload. So we're saying we implement create and preload. So this means game knows to call back to these particular functions when those events occur. All right, so that should close that off. And close out that call. Close out our constructor. All right, so I guess we should go ahead and do preload and create. All right. Create's probably pretty obvious. It's called, the order these things are called is actually very important. Create's actually called fairly long into the process. So the constructor is obviously called the very first thing that's called. Preload is called pretty early on, and it's for quite literally what the name says, preloading of assets. There's a loader behind the scenes that takes care of things for you, and this is nicely going to that's where we're going to load everything. Now, in this particular game, we're going to load all of our assets right up front. It's going to be a little bit convenient. So it's a little inconvenient that they're not right where you're actually using them, but it's nice to have them all loaded out of the way. You don't get weird load orders, etc. So, like I said, we're gonna preload everything right here when our game first starts. We're also going to be adding our states after the fact, but we haven't created any yet, so we're going to have to come back to that. So finally, all right, so there we created our game. There's a very basic skeleton of a game class. Now we need to wire up an onload handler for our window. This basically just saying, this is just one of JavaScript. Like I said, TypeScript is just JavaScript. So we're basically overriding the .onload handler or event for the window object. And this is an anonymous function. And this little guy here basically says capture our state. So that captures in, it makes this the right this. It's not actually needed in this case, so I don't really know why I did that, but that is the syntax for a lambda or anonymous functions in TypeScript. So now that we've got one, we just create an instance of our game equals new game.extreme walking simulator. Done. So what's going to happen is our HTML file loads. It calls our app.js, which is generated by app.ts, and that in turn, a Windows onload will call. So when we get the window onload event done, we create a new instance of our game. Our instance of our game now knows to call create and preload. So first it's going to call preload. We load all of our assets in. Then it's going to call create. Create's kind of an important call because it's actually going to be what gets things going. I'm not actually sure what will happen if I run this because it doesn't actually do anything yet. Yeah. So there's our game so far. So now let's go ahead and start looking at states. I'm going to jump ahead slightly. I'm going to start adding all of our assets in. I'm just going to bring them over from our existing project. So add existing item, and I will pull them over from the version of this I've already done. So we need our graphics file. There's our game over, our hero sprite sheet, our XML file for our sprite sheets. I'll talk about all of that in detail. Scene 720p and our title screen. Okay, so left to right, basically, this is the screen that's going to be displayed at the end over. This is the animation used for the idle animation. This is the control for that. This is the walking sprite sheet. This is the control for that. This is the background scene that we're using for our endless walker. And then finally, this is the title screen. All right, so those are the graphic assets we're going to go ahead and add. Once again, they're all going to be on the GitHub site, so if you want to use the assets, they'll also be on GameFromScratch. I will also include the blend files I use to create all this, so if you want to tweak it, play with it to your heart's content, go get the files, change it up however you want, create new animations, do whatever you want. If you have any specific questions about how certain things go, let me know. I can probably make a tutorial covering that as well in the future. But those are the graphics we're going to use, and while we're here, let's just go ahead and grab our audio. Add existing items. And we'll go over to, okay, that's the right guy. Sounds. And this is the same thing in 3 different file formats. We'll talk about that in a minute. But basically, I just went on my iPad and played around with a synthesizer for a few minutes and created a really horrible title graphic. But it does show you how to play audio. I will cover that in a minute. But so there's all of our assets coming in and shown. So next thing we want to do is actually we'll go ahead and preload them, and we'll use them all later on. So we have 3 classes of graphics. Sorry, 3 types of things to preload. We have our graphics, we have our sprite sheets, and we have our audio. Now, first, let's load our graphics. This.game, we can do a lot of that. Game is basically the global controller phaser object. It's got a bunch of built-in class instances for us, like this instance of the loader class, .load image. And what you do is you give it a key that you're going to refer by it later on. So this is our title image we're going to load, and then path to it, or the URL. All right, so that's our title screen. Our scene background. Yeah. What did I call you? Oh, lowercase. Scene 720p.png. And finally, our game over screen. Gameover.png. Alright, so there's our graphics all loaded. Again, Phaser's going to take care of all this for us in the background, but it's nice to get it over with right up to the front. The sprite sheets were provided. We created them externally. I'll show you some of the process I used to create these things very, very quickly. But it's created externally using a program called Texture Packer, which exports it. We exported in Starling format, which is a Flash framework that happens to be compatible with the phasers format. And what it does is it creates an XML file. I'll pop it open in a sec so you can see exactly what it is. But we're going to go ahead and load that XML file. It's a texture atlas XML, like so. And we're going to do one for each of our animations. So we have a walking animation and we have a idle animation. And I was very bad about mixing case, as you can see. You should probably use a much better, much more consistent naming convention than I have here. But that's what I did. Alright, so we got hero walking and then hero idle. So that's loading our two animation sets. Graphics.hero idle, I believe. Yeah. Alright, and our sole lonely audio effect is game.load.audio. There's also audio sprites, which allow you to pack a whole bunch of different audios into a single file. There's a lot of limitations on HTML audio, and audio sprites gets around a lot of them. Again, GameFromScratch, the tutorial covers it. We're not going to use any real actual sound effects in this game other than the music to start. But if you're creating a game with a bunch of quick, replayable sound effects, you're going to want to use audio sprites. Once again, there is a tutorial covering that. I'm not going to go into a detail here. In this case, we're just using a normal audio. The actual format, once again, is very similar. Key, and then in this case, we're actually going to be providing 3 different files. Like so, in an array. And I'm running out of room. All right. Title song.wave. All right, so that's an array of strings of paths to our audio files. And you'll notice we did 3 different versions of 3 different file formats. And that's because the browser support for different file formats is different between each different web browser. For example, Safari does not support the OGG format, whereas I think Chrome supports just about everything. Firefox supports just about everything. Internet Explorer supports MP3 and WAV, but not OGG, I believe. It might support OGG now, I'm not sure. But basically, different browsers support different versions. And it's annoying. So this is going to blow up the size of your game a bit. But fortunately, what happens is Phaser will sit there and go, okay, this is the browser, and serve out the right or the best version. So what we're doing is giving it the maximum options to work with. So for this title song, there are 3 different files that it can work with. And then depending on what the browser it is running in, it will send the appropriate one. All right, so that's our preloaded audio, sprite sheets, and graphics. We're going to use those later on. The key thing to remember is you're basically passing in a key and the URL to the asset, or the assets in the case of multiple. All right, so there is our preload pretty much done. Now we want to go ahead and create some states. In this case, we don't have any states yet, so we need to actually make one. Let's go over to our states folder here, and we'll add a new TypeScript class to that. And we are going to call this guy, let's go with title screen state.ts, like you. All right, so now we are going to namespace consistently as GameFromScratch, just so you don't get name collisions if some other variable is using the same type. And we need to export out this class so we can actually use it. Export class title screen state, and we are going to extend from phaser.state. Like you see, TypeScript has nice class inheritance, and this way you don't have to do the dot prototype inheritance that you would with JavaScript. It does make your code quite a bit cleaner. Once again, and you're going to see me consistently do this, we're going to take a reference to our game class, which is of type phaser.game, and we're going to take a reference to our music file, which is a phaser.sound. We're also going to have a title screen image, which is a phaser.sprite. All right. I'm not entirely sure why I did this the first time, but I'll be consistent with my own code. I did an empty constructor. My soul says that that was totally not required, but there might have been a reason. I probably had code in there that I ultimately removed, but there's no harm in having an empty constructor. So next up, we need to actually do something with this guy. So when the state is created, it is going to call the create method. So let's go ahead and override that. Like so. And in it, we want to go ahead and load our title screen image equal, and then this dot, oh, it's in the state, so we'll add it directly here, dot add, and we'll add a sprite. And we're going to add it right at the origin, and we're going to use title. Once again, oops, unpin. Title is now going to be this guy. So that's what this value here is. It's loaded globally into the game object, so it's accessible to us. So we use the key to access it later on. All right. So that is loading our graphic sprite for our title screen. And now we're going to do a little neat trick, and we're basically going to scale the sprite to be whatever size our screen is, ideally. Title screen image dot scale dot set to. And it's this dot game dot width divided by this dot title screen image dot width, and this dot game dot height divided by this dot title screen image dot height. All right. Okay, so our graphic will scale up or down based off the resolution that the window's passed in. You'll see later on, this is a little bit less necessary because of that one line of code that I don't actually cover on GameFromScratch. I'll show you it in a bit. But TypeScript, Phaser has some really nice scaling built in, so that's pretty sweet. Okay, so that code there loads our image, creates a sprite for us, and then scales it to the full extent of the screen. Next, we're going to create our music file. You're going to see there's a very consistent way you work. Once again, you use the key. This is the asset key we used when we loaded it earlier on. Let's set the music's volume equals 100%. This dot music dot loop equals true. We're going to loop it forever. This dot music dot play. Okay, so now what we have is we have a state that is for our title screen. It's going to come in, it's going to load the image, it's going to display it full screened or full windowed. Then we're going to load our sound and then play it. So let's just go ahead and see where we're at here. Now, first off, let's go back to create, and we actually have to call our state. It's pretty easily done. In our create method, we will call this.game.state.add, and we're adding the state to our game. Title screen state, like so. We pass in its type, name from scratch, dot title screen state, like so, and we're going to pass in the value of true. That value of true says, run me right away. So it's going to create the state in a running state. So this is going to become the active state as soon as we've called it. And here's that magic line of code. This is not covered on GameFromScratch. This.game.scale mode equal phaser dot scale manager dot show all. This will cause the game to scale and handle resolutions magically, so we don't have to do any work. It's a great thing. It probably completely and utterly renders this functionality useless, but it works. I'm staying consistent with what I originally wrote. So that isn't covered on GameFromScratch. It's something I'm going to have to write a tutorial about in the future. But this single line here makes it so that Phaser does all the scaling so it fits the window as best as possible. There are other modes for letterboxing, etc. But we'll go ahead with show all. So now we can just go ahead and run this. We should, if I haven't made any mistakes. Now see the title screen. Oh, I made a mistake. GameFromScratch is undefined. Okay. Valuable lesson here. Remember this guy? So now that we added in our new class, we need to link it in. We need to actually call it. So we're going to come here and go script source equals, and then game objects. Oops, wrong one. let's try that again. States, and then it is title screen state, and then JS, like so. Close that off. All right. So each time you add a new class, because of the way we're doing things here, you need to link it as a script. There are options. There are AMD and required modules that you can do, so it makes it so that this is handled automatically behind the scenes by TypeScript, but it's problematic, so we're going to stay away from that. All right. So go ahead and run that now. Okay. Here, let's rerun it. There you go. So there's our audio playing in the background, our sprite nicely displayed, and as you can see, it resizes as the window goes. So auto just ended, and there it started again. Aren't my musical talents amazing? So again, those are standard WAV files being played. Sound effects are played almost the exact same way, but as I said, there's also something called an audio sprite you should probably look into if you're doing a real-time game. So, all right, let's keep going. So that's your first state. Your title screen is now in and done. We're now going to go ahead and add a next state. This state's kind of important because this is actually your game. I imagine you want to have a game state at some point, so let's go ahead and create that. So add new, and it's TypeScript file again. And then this one is called gameplay state, TS. Once again, these names mean nothing. Those are just the ones I happen to pick. And right off the hop, I am going to take care of that immediately so I don't forget. So gameplay state, like so. All right, so we're linking it in. Now that we've created it, we go to it, and we actually should probably write something. It's actually going to be a very, very simple thing because we're going to be moving most of the logic out actually into the game objects. So use our game from scratch namespace again. We need to export out our class. It is called game. Gameplay state. So once again, it extends the phaser.state object. We'll grab a reference to game. I do that as much out of habit as anything. Our player, phaser. Oh, I haven't created these yet. All right, we'll come back and add those later on. Once again, I created an empty constructor, and I don't really know why I do this. It's probably not required, but I'm staying consistent to the code I've already written. So, why are you getting angry at me? Why are you angry? Oh, extends. There we go. Okay. And then once again, we have our create method. And to be honest, it's now kind of useless because we need to go ahead and create some game objects. First thing we're going to do is we're going to go ahead and create our player object. It's in game objects here. We are going to call it player. Add new TypeScript file, and we will call him player. So I'm a player, bitch. All right, so we got our player. Go ahead and create another module, our namespace, like so. Let's not make the same mistake. I'm going to put my game objects above so that if there's any dependency issues, they're resolved first. That'd be game objects, and that is now called player.ts. So, all right, so our game object is now included in. We'll go back to our player class. Our player is going to extend sprite. Okay, we're gonna have it in enum. This is not available in JavaScript, but it's a handy little guy. If you've used C++ or C or Java or whatever, you've probably seen these. Basically, it's a single variable that can have a set of fixed values. I'll show you right here. So we can have two particular player states going. I'm using the word state far too often here to be different things, but our player can be doing two different things, walking or idle, and this enum is going to be responsible for determining which one it is. We'll use it quite a bit in the code, actually, so we're going to declare that enum quickly, then finally, let's go ahead and take a reference to our, oh, I made a class. Export class player extends phaser sprite like so. Squiggly brackets. Now we're going to need a number of variables. First off, once again, reference to our game. We have a player state. And I'm going to spoiler things a little bit, but we're going to handle the right arrow, which is a phaser.key. The left arrow, phaser.key. And escape, which guess what, is a phaser.key. Again, all covered in tutorials on GameFromScratch. You can see those later on. Next thing, we have a member variable called walking speed, and it is a number. Same time, we also have a const, or as close as you can get, which is a public static max underscore speed, which is also a number and has the value of 30. This is actually the frame rate. So our sprite's going to be recorded at 30 frames per second. The fastest you can walk is then basically entire frame rate in 1 second. So 30 frames in the second is the speed we're going to go to, and our walking speed is going to determine the pace of up to 30 frames per second. And we're actually going to end up using it as a percentage. So I don't know why I made it as a value out of 30, but anyways, on we go. Let's go ahead and create our guy. And we're going to do it in the constructor. So, once again, constructor is what it's called when a class is created. And it's a TypeScript thing, but Phaser itself has a number of constructors. Let me just show you. Phaser Sprite, for example. And bring up the documentation. You will see here its constructor takes these values. But we're actually only going to use a couple of them because we're creating a fake sprite in a way. Because we're going to be changing the graphic that we're going to be using. But we want to display it as a single sprite. So that's why we're extending sprite down. But that's the underlying constructor for Phaser Sprite. As you can see, the documentation for Phaser is very good. You'll be referring to it very often. It maps very well to TypeScript too, so if you're using one or the other, it's fairly clear. But this is our constructor's parameters. It's going to take a reference to, give me focus, our game, our position, and our position's y-axis. All right, there you go. So that is our class. One thing you're going to ultimately have to do is call up to your base class, which we do with a call to super. And we pass in game, x, y. The graphic to use, we're going to start by default with the hero walking frames and the 0th frame. Now, let me explain that for a second. Our sprite sheet, if you've never encountered them before, is in here. Hero walking looks like this. So basically, it's a bunch of different graphics all on a grid. They're loaded at once. Very good for performance as opposed to loading them separately. Also, if you're using WebGL, it keeps them as a single texture bind, which is a very good thing for performance. So this is a sprite sheet. It's called hero.png, and the tool I use to make it is Texture Packer, which is right here. And just show you quickly. All you do is you drag the files you want to use in here. Let's see if I have any still. Temp. Nope. All right. You drag your images in here. You say how you want it to generate, what file format you want, and export. I've got a couple tutorials on GameFromScratch about that as well, so I won't cover into it. But basically, our sprite sheet for our walking animation is one single image file with a bunch of little separate rectangle worth of images. And then there's this XML file that goes with it. And as you can see, all this is basically saying frame 0001 is at this location, this width, this height, and this is how you can use it to figure out where the graphics are. The nice thing is Phaser does all the logic behind the scenes. So all you had to do was app.ts was load it. and it did all the work for you. So what we're doing now in our game playing, not our game playing, our player state right here, is we're saying use that graphic and that frame. That's it. Okay, so that's where we're going to default with. We're going to be changing that quite a bit though over time. So back to our constructor. Now that we've got our parent called, first thing we're going to do is go ahead and take a reference to our game. Set our walking speed to default at 0. And now let's get our input wired up. So if you press the right arrow equals this dot game dot input dot keyboard dot add key. This wires up to say we have a keyboard handler here, or sorry, we have a key here, and we are going to handle the value of right, like so. And now we have a handler, right arrow dot on down. So when the key is pressed, add an event handler because you can have multiple. And we give it a class, the function to call, which I haven't created yet, called move right, and the context, which is this. Now, I'm not going to do cut and paste coding because that always ends poorly. So left arrow equals this dot game dot input dot keyboard dot add key phaser dot keyboard. Yep, that was predictable enough. And this is going to be left arrow dot on down dot add, and then player, spelt wrong, player dot prototype dot move left. Obviously, we're going to have to create a method called move right and move left. And finally, let's wire up our escape key. This dot escape equals this dot game dot input dot keyboard dot add key phaser dot keyboard dot escape, like so. This dot escape dot on down dot add player dot prototype dot what I call it, game over. And this context, like so. All right, so that's our 3 keyboard handlers. We're going to handle the right arrow being pressed, the left arrow being pressed, and the escape being pressed. Right arrow is going to cause us to speed up. Left arrow is going to cause us to slow down or ultimately stop. And escape is going to exit the game or bring us to the game over menu anyways. So those are all wired up. Now we go ahead and call our base class. Now let's keep in mind, you can't call any of the methods from Sprite until the super has been called. So now that it has been called, what we want to do is we want to go ahead and move our anchor pointer. As it stands, the default anchor point for a graphic is the top left corner. So that means it's drawn relative to its top left. When you're dealing with a walking sprite with their feet on the ground, you often want to actually use the bottom left instead. And we're just going to go ahead and do that. So set the anchor instead to use normalized coordinates here, so they go from 0 to 1. So this is left to right. So 0, 0 is as far left, and top to bottom, and 1.0 is as far down. So what we're saying is bottom left corner of the sprite is the anchor point to do all their drawings relative to. And this dot start idle, which is a method we are going to create in a second as well. All right, so we got a couple of methods to make here. We have, all right, first off, let's do move right. This is what happens if you press the right arrow key. First thing we do is if this dot player state is not idle. So if the player is not idle, let's call this dot start walking, which we are going to create in a second. And scroll down here. All right. So if the player isn't walking when you hit right, call the start walking function. Otherwise, if this dot walking speed is less than player dot max speed, so in other words, if they're not walking at full speed yet, this dot walking speed plus plus. And then finally, this dot animations dot current animation.speed. So it's one thing to actually increase the walking speed. We need to actually tell the animation to speed up as well. This will make more sense in a second, don't worry. So let's this dot walking speed. So basically the gist is, if the player isn't walking, start walking. Otherwise, increase their speed by 1 and tell the animation to speed up as well. Okay? Now, let's go ahead and do the start walking call. Alright, so we call this start walking right here. So start walking. And this is going to start the player walking. So first thing first, player state equals player state dot walking. So the player is now walking. We will start with a default walking speed of 5 frames per second. Sorry, my bad. Walking speed equals 5. That means that it will go through 1, 2, 3, 4, 5 frames per second. So then the next second will be these 5, the next second will be these 5. That controls your animation playback rate. All right, so that's the walking speed set. Now the magic is this dot load texture, and this is what changes the animation being used. So we now want to use the hero walking sprite sheet. Start on frame 0, like so. The game doesn't have any segue between animation types. If you were doing like a professional quality game, you really would transition your animation so that you can move from. So right now, if you go from like walking to jumping, if there was jumping in the game, you would have to have a transitory animation of some kind. And I don't have any of that there. They're very simplified in this case. But this .animations.add. And we'll add an animation called walk. And we're basically just saying this texture has an animation called walk, and that's because we didn't provide any frames to use. It's going to use them all. So what we're saying is this entire animation is known as walk. You can also set it to use frames 0 through 30 or walk, 31 through 37 or run, in case you have a bunch on the same sheet. But we're doing 1 sheet per animation, so we can name it singularly. So finally, we need to go ahead and play that animation. So this .animations.play, it's called walk, and we pass in the walking speed as our frame rate, and we want to loop forever. So that means it will go through the entire animation and then go back to the first frame. So that's what happens when start walking is called. Now, as you see, we need a start idle. Start idle is going to be very similar. This starts the idle animation frames, and this is done via this dot player state equals player state idle, and this dot walking speed equals nothing. This dot animations add dot idle. Oh, I suppose I should add my animation. This dot load texture and hero idle. So we load our idle sprite sheet in instead of our walking one. Like so, and we start on frame 0. Add the animation, and I suppose we should go ahead and play said animations. And in this case, there's no speed for idle. We're just going to play it at a constant 15 frames per second frame rate. If you want him to fidget slower, lower that number. If you want him to fidget faster, increase that number. And loop that one as well. All right, so there's when we start idle, or when we start not so idle. Finally, I say, is this enough to? All right, so we got move right, start walking. Yeah, let me just sub out move left and game over. So, all right. I'm going to go ahead and change one thing here to stay consistent with my code. Actually, on the left-hand key, I actually didn't call it move left. I called it the horrifically named move less right, which is technically right, because we're always moving from the left to the right in our game. So when you hit the left there, we're actually calling move left right. So now is where I varied. So move left right, and we shall therefore, when we move left right, we want to slow down the character. So if this dot player state is not idle, so if the character is not currently idle, then what we want to do is this dot the walking speed is decrement it like so, and then if the walking speed, I need my this dot walking speed is greater than 0, then we update our animation playback speed with our new animations.current animation dot speed equals this dot walking speed like so. So if we are still moving, let's just update our speed. Otherwise, this dot start idle. Switch into the idle state. So if they get their walking speed down to 0, we're going to go to idle. Otherwise, we just lower the speed down and update the animation accordingly. All right, I think that is everything important for now. Let me just go back to our gameplay state. All right. So now we're back in our game. Now that we have our player, we need to go ahead and create him. As player, as GameFromScratch.player, like so. And now we just create one. This dot player equals new player, this dot game. And we will put him at 0 and near the bottom of the screen, minus 50 pixels. Like so. And now we go ahead and we add him. So this dot game dot add, and since we already created one, instead of creating a new one, we use existing, and then this dot player. So that adds it to our game scene. Finally, no, I'll do that later on. Okay, so in theory, if I haven't made any mistakes, we should now have a player up on screen. Nope, made a mistake. All right, player.ts. Semicolon expected. All right. You know what? It's very hard to debug code in this presentation mode. Just be right back. All right, that was stupid. Okay, so here's my bug. Can you spot it already? That's it. Don't do that. So I accidentally typed into the .ts file as opposed to the compile.js file. So in theory now, at least I'm guessing that was my bug. I'm going to go ahead and run it. There we go. So there's our game. Sound effects playing in the background. Oh, I didn't wire it up to go to the next event. Okay. Guess we actually need to change states. So let's go back to our app here. Remember back here where we created our initial state, our title screen state? Well, now we have another state, right? We have our gameplay state. So let's go ahead and create it now. This.game.state.add, and then game. Did I capitalize the P? Yes, I did. State, like so. And it's GameFromScratch.gameplay state. And this time it's false. We don't want to run it right away, at least not at this point. So we got to register our state, and most importantly, now we actually have to, in our title screen state, we need to transition out of it. So when the user presses the button or clicks on the screen or something, we need to go ahead and change the state. So let's go back to our title screen state here. And we're going to have to extend this guy a little bit. First off, let's create a method for title clicked. And this is going to be called when the user clicks the title. This.music.stop. So we stop playing our music now. And then this.game.state.start. and then gameplay state. So this is key. This is what actually fires off. It'll end this state and go to the next one. So when the user clicks on the screen, this function will be called. It stops the music, starts the new state. Now, however, I should actually wire that up. So we need to come back here and go this dot input in the create handler. This dot input dot on tap. Dot add once. This dot title clicked and the context like so. So now when they click on the title screen, it will go to the next gameplay state. So this is how you transition between states. Very important. So now let's go ahead. We'll run that. Bam. Okay, so there's our title, and I click that, and I have an error. Get frames index of null or undefined. I made an error. Okay, just a second. All right, I'm back. Unfortunately, I'm going to have to do a bit of video editing here because I accidentally hit F10 while doing debugging, and this is the same as stop recording on Camtasia Studio, so I just sort of stopped recording. So anyways, I'm going to splice these back together, but I did find the bug. It's a bit of an insidious little bastard, but pretty common in development. So what's happening here is I'm getting an undefined error on this guy. Inside this call anyways, as this dot frames is throwing an undefined error. And what it ultimately boils down to is I made a mistake way back here. This loading the atlas call, I passed in the atlas, but I didn't pass in the image file. So here, let me just bring up the code suggestions, and you'll see what I mean. So the second parameter is actually supposed to be the URL, and the third is the data. So what I should have done is graphics/hero walking.png, like so, and graphics hero idle.png, like so. So that was the source of our bug. So now if I go ahead and run this, there's our guy currently sitting idle. And now if I press the arrow keys, absolutely nothing happens. All right, well, that was fun. All right, back to our player. See if I've actually wired it up. Right arrow, that, call, move right. So it should, coming into here. Now, I'll just do an alert because I don't want to kick off the debugger, because that'll stop my recording. I really need to find out if I can remap that hotkey. So now I'm going to hear, okay, so it is firing, so it's just not doing anything. What's our player state set to? Player state. That's probably my problem. Start idle. Okay. All right, another small bug here. This is not equal. It should be equal. So in other words, if the player is idle, start them walking. Otherwise, increase the speed. So that was probably my mistake right there. So let's start this up again. So there's our player in the idle animation. Press the right arrow, he starts walking. Press the right arrow repeatedly, he speeds up. Press the left arrow repeatedly, he slows down until nothing. And then back to the idle animation. So there you go. We now have a character that is movable, controllable, and walking in the world. Now we should probably go ahead and add a little bit of movement to him so he actually moves while doing that. And that is simply a matter of handling his update function. This is inherited from sprites. We're actually going to be overriding a method from Sprite called update. This is called per tick or per frame. And this is where you update the position, etc. of your sprite, or the logic in your sprite. And that logic is fairly simple in our case. What we're going to do is this dot player state equals player state dot walking. So if we are walking, then we increment the x, and then we're going to take this walking speed divided by the maximum possible speed. So basically we're turning this into a percentage of total max speed. Like so. And we're going to multiply that by 60 seconds 60 seconds over the next millisecond. This game.time.elapsed second, like so. That will smooth out the frame rate. So we're only doing it based on the amount that we're updating. Otherwise, the animation would run at a different speed on different computers. That calculation. So basically, we're giving the character a movement from the frame rate as a ratio of its maximum frame rate, but we're smoothing it out by the amount that we've updated since the current frame in milliseconds. So there's that. Okay. So now we got that in place. Now, actually that's it for now. We will come back to this guy later on when we add our scene in. That should be sufficient to get us moving. Now I just need to figure out why it's angry at me. I'm missing a bracket. So, that should be good, in theory. So now when I press right, we actually start to move, and I speed up, and there we're moving at full speed until we go off the screen. There you go. So next up we actually need to get a background or a scene going. Now unfortunately I way underestimated how long this was going to take. I was hoping to get it done in an hour. I'm sitting right about an hour right now, so I'm guessing we're a little over halfway done. So overall, I think we're probably going to have to make this a two-part video. So I hope you enjoyed part one. Stay tuned for part two. I'll be releasing both of them at the same time. Just splitting them into two files to keep the download size a little bit more manageable, or the upload size in my case. I hope you enjoyed that. I hope you enjoyed part two. Stay tuned.